Welcome to Basics of Special Relativity, Lecture 1, Introduction. This course, Basics of Special Relativity, will cover the most important starting concepts that you need in order to understand special relativity. The course will cover the core concepts similar to those given in the first few weeks of an undergraduate course in special relativity. This course is suitable for an undergraduate with some physics background, an ambitious high schooler, or an interested layperson. Now, we should warn you that there will be math. What you're going to need is basic algebra. You won't need any calculus. If you don't have the math background, you might get some of the flavor of special relativity, but you won't catch everything. If you are serious about learning special relativity, you might want to use these lectures in conjunction with a good textbook. Here's one way of describing the contents of this course. So let's say you're watching a science fiction movie, and that movie has characters traveling in spaceships near the speed of light. Then weird things happen, like the characters in spaceships age more slowly than people back on their home planet. If you want to know if that stuff's real, then this is the course for you. Okay, now for an actual outline. So this course will cover the following topics. First, the axioms, or basic starting principles of special relativity. Here we'll define some terminology and we'll discuss the basic assumptions upon which relativity is built. Next, we'll give an overview of the consequences of the axioms of special relativity. So these axioms lead to some really weird effects. We'll give an overview before we get into the details. Then, the next thing we'll look at is the relativity of simultaneity. So, one of those weird effects of special relativity is that two events that are simultaneous to some observers will happen at different times for other observers. After we look at that, we'll see the Lorentz transformations. So here we get into some math. We'll need the Lorentz transformations to derive the rest of the results in the course. After that, we'll look at the relativity of simultaneity again. So now that we have the Lorentz transformations, we'll go into the relativity of simultaneity in more detail. Next, we'll look at length contraction. So another weird effect of special relativity is that objects get shorter when they travel at high speeds. After that, we'll look at time dilation. So another weird effect of special relativity is that clocks moving at different velocities show time passing at different rates. After that, we'll look at the twin paradox. So this is a fun paradox that comes up in special relativity, and it causes a lot of confusion, and it is very rarely explained well. We'll go into it in detail and show how the paradox is resolved. Okay, so with that, let's get started.